So these don't diverge or converge. That one's just a constant amount lower than the other one is. OK. How about constant elasticity? Is Ned Lieb here? Sorry, where are you? Oh, there you are. OK. What is the marginal revenue curve associated with this demand curve?
Cubes of the negative amounts? Negative. I'm sorry, I got no sleep last night.
Yeah, so does anyone else want to try to do it? Kevin, right? No, George. Go ahead, George. Yeah.
So
Kevin's back there.
the revenue curve would be q times 1 over root q, which is just root q. And then the derivative of that would be 1 over 2 root q.
Yeah, which is sort of like this, right? Except half the size, right? Exactly. So this one is a constant fraction of this one, right? And that's going to make it actually converge with this, because as the price declines, they're going to get closer and closer together, right? OK, so here's the pictures. So remember, for the concave one, they're going to diverge increasingly quickly. For the linear one, they diverge at a constant rate. For the exponential one, there's a constant vertical distance between them. And for this one, they're in a constant proportion to one another, and so they converge. OK, now how do we find the optimal price? Well, imagine that the marginal cost curve were just constant at wherever the axis happens to be in this picture. Then we'll take the intersection between the marginal revenue curve and the marginal cost. That'll give us the optimal quantity. And then we can figure out the optimal price by drawing a line up to the demand curve and then over to the axis. And we can do that for each of these curves. Now, the different shapes of these curves is going to be important later. The more concave these are, the more that they tend to diverge as price gets larger, the more that that marginal surplus, the difference between them, increases with quantity. And the more convex they are, see, this is somewhat convex, this is very convex, the more they'll tend to actually converge as the quantity increases. OK. So another way to write marginal revenue is that it equals price times 1 minus 1 over the elasticity of demand. And Agnès, can you derive why that's the same as the marginal revenue?
I have to derive B.
Derive why this equation is equal to the marginal revenue. Marginal revenue, again, is price plus price prime times quantity. Why is that equal to this? You can do it on the board, maybe, or you can try to explain it. Probably it's easier on the board, but whatever you want to do. OK, you want to prove that the marginal revenue is equal to price times 1 minus 1 over the elasticity of demand. Again, you can do it on the board if you want, because it involves a little bit of math. Yeah. Yeah? Epsilon is the elasticity of demand. Okay, well, why don't you try factoring out a P of Q from both of the terms in this equation? So turn this into P times 1 plus P prime divided by P times Q. Right, you can factor out a P from both of the terms, right? So we make this P of Q times 1, right, minus P prime times Q over P. Now that's 1 over the elasticity, isn't it? Negative 1 over the elasticity, isn't it, right? Because P prime is the same as 1 over Q prime, right? By the inverse function theorem. And this is Q prime divided by Q times P, which is 1 over the elasticity, right? Because we do the negative for the elasticity of demand, we do a negative, right? So this is equal to 1 plus 1. Oh, sorry, there's a plus here. And so this becomes 1 minus 1 over the elasticity. Okay. Good attempt, though. Okay. So notice that the marginal revenue, therefore, is always negative whenever the elasticity is less than 1. And therefore, you're always going to want to reduce your quantity below any level where demand is inelastic. Anytime demand is inelastic, you'll reduce your price. Okay. Elasticity of demand determines monopoly power is another implication of this equation, right? Because if the elasticity is really large, this term is going to be close to 0, and so the price, this will basically just be the price. Elasticity is small, then this is going to be much smaller than the price, right? So this sort of summarizes the notion that important players in the market are the ones who want to charge a price that's much above cost, right? So this yields a canonical formula. If we just rearrange this, we get that price minus marginal cost divided by price is equal to 1 over the elasticity of demand. So your markup, how much you charge price above marginal cost, relative to the price, is equal to the inverse elasticity of demand. Yeah.
So this holds also for competitive firms, right? Their elasticity will just approach infinity. So we'll end up with that 1 over.
Exactly.
Elasticity on 0.
Exactly. So every firm you can think of as being a monopolistic firm, right? That's the sense in which it's not how many firms are there, it's what are we thinking about? Are we just thinking about this firm and its direct effects, or are we thinking about all the other firms in the industry? Okay. So, we could also do a markup relative to marginal cost rather than relative to price. And then this would be 1 over the elasticity minus 1. Or we could just do the ratio of price to marginal cost, and this would be the elasticity over elasticity minus 1. Or we could just do the absolute markup, price minus marginal cost, which would be price over elasticity. All of these are different ways to measure the market power of a firm. None of them is particularly more right than others. It sort of depends on the context. The standard Lerner index is useful because it just gives it in terms of 1 over the elasticity. It's sort of the simplest. Price-cost ratio is useful when we're trying to think about firms' profits when there's constant marginal cost, right? Because that's saying, like, how much profits per unit are they getting roughly, or something like that, right? Well, I mean, that's actually the absolute markup. But the absolute markup is useful when prices are not positive, which can occur when marginal costs are negative. How could marginal cost be negative? Imagine that I'm a newspaper, right? and I'm trying to get more people to read my newspaper, but I make more money off the advertisers than it costs me to print the newspaper, then it doesn't make a lot of sense to think about this Lerner formula, because my marginal cost, it could be negative. I might even give away the newspapers for free, right? Yeah, go ahead, Jacob.
Calculating the elasticity here.
Yeah.
At what quantity are we calculating?
At the optimal quantity.
For the society or
for the firm.
Okay.
Well, in other words, the firm's going to set it. The elasticity could depend on the quantity,
Yeah.
and then they're going to set it to the point where this markup is equal to the inverse elasticity. So like another good example of this is credit cards. So credit cards often give you points for using them. So that's like a negative price. And what is an elasticity at a negative price? It sort of doesn't make very much sense. But the reason is that their marginal cost is negative as well, because they're charging something every time you use your card to the stores. Right? OK. So of course, in order to set prices, the firm needs to know what its demand is, right? Otherwise, the quantity that it produces and the quantity that is demanded are not going to be the same necessarily, because it's got to produce something and it wouldn't know how much to produce, right? So, and to make the optimal price, the firm needs to know what its marginal revenue curve looks like, right? Now, in the past, firms sort of had to just guess at this stuff, and then maybe they got it approximately right, but they couldn't really implement the economic science that we're sort of doing here, right? But the internet has really created a revolution in this, because it allows firms to do all sorts of real-time experiments. And many companies do this all the time. So I don't know if you guys have ever tried doing it, but if you go on Amazon 3 or 4 times in a day, you will often get different prices. And the reason is that they're experimenting to see what the effect of changing prices are. On eBay, this is particularly common, because there are often sellers that sell tons of stuff on eBay, and they will experiment by changing, say, in an auction, what the reserve price is. The reserve price is the minimum price that some bid has to go over in order for the auction to clear. And they can do that on, say, the identical object over different days, or maybe even at the same time. They just hope that people don't look at the prices of multiple different auctions, right? Now, in an auction, you have something that's quite a bit like a demand curve. Well, it's not quite a demand curve, right? Because there's multiple different people bidding. But in what sense is there sort of a demand curve in an auction if you can change your reserve price? Jacob, what do you think?
Well, I'm thinking that initially at low prices, you would have, I mean, if people were bidding as soon as they wanted something, just jumping at the last second, you're going to start with a lot of buyers.
Yeah.
And then as the price goes up, different people will drop out of the auction. So
Yeah.
you see basically quantity demanded, those prices fall.
But think about it from the perspective of the person who's running the auction.
Mm-hmm.
They have to set an optimal price. In what sense do they have sort of a demand curve as they change their reserve price? What happens if they set their reserve price really high?
Then people may not bid on that at the start.
So the probability they end up selling it goes down.
Mm-hmm.
What also happens? What's the benefit that they get from setting a higher reserve price?
They won't sell it too low.
Yeah, well, in particular, imagine that no one bids above, that only one person bids above the reserve price. Then they get to charge that person the reserve price rather than just charging them 0, which would have happened if they set no reserve price, right? So you can think that as they change the reserve price, the average price at which they make a sale goes up, but the probability of them making a sale goes down, and that traces out sort of an auction demand curve, right? OK. Yeah.